Hi, everybody, and welcome to another episode of the Papers Podcast. Today, lucky you, it's time for Methods Consult, but with a twist. And why? Because with me, friends, is Jon. Jon and I are going to have a conversation today about a number of things that started way back a few weeks ago. But first, Jon, how you doing?
I'm doing great, Lara, and thankfully the hegemony of the Varpio methodology is slowly being cracked.
Oh, you called me the hegemony. I don't know how I feel about that.
I don't know what that word means. I had to go look it up. I don't know. The Google does not translate stuff for me into Jon.
I had the great fortune recently to go to the Mayo Clinic in Rochester. And if y'all ever have the chance to head over there, you have to go and meet the great group they have. Fred Hafferty, Alex Niven, Ashok Patel, Ellen Usher, Adam Sawatsky, Elisa Hall, and Dave Cook all call that institution home. And it's a wonderful organization, a wonderful community. And I had such a great time there. But Jon, there's a reason I'm asking you to come chat with me after I was at the Mayo, because, Dave Cook is a wonderful scholar, a powerful thinker, really a post-positivist, perhaps even a positivist. That's fine. But there was a whole bunch of conversation going on. At one point, I found myself writing notes about sample size and sampling, and I wrote a lot of words, and I spelled them wrong, and I don't know what they mean. So I thought, you know what we need? We need a methods consult with my friend Jon. So Jon, today, can we talk about sample size?
We can't. The timing's great. So Dave sent me an email. So Dave and I, he's a colleague I really enjoy. We've done some work together. And he called me out on doing some back of the napkin stats on one of our episodes on sample size and sent me a paper. I think it's an excellent paper I hadn't seen before. It's published quite a while ago. Probably one of the reasons why we never have covered it in the podcast. But it was published in Advances in Health Sciences Education in 2014, and it's called Got Power. And we'll use that maybe as a bit of a jump off for this discussion. I'll also shout out Rose Hadala, who is the co-author on that manuscript, who is also a friend of the show and just a great human being all over. So sample size, huh? Are we finally not talking about autoethnography? We're going to do some math. I'm super happy.
Well, I'm not sure I am, because to me, sample size is how many people are in your study, right? So that's just the N. But I understand on the quant side of the house, there's a lot going on when we talk about sample size. So maybe you can tell me a little bit, like, what's the issue?
I think most of us bump up into it is that if you are doing any kind of consort statement or any following any kind of guideline for an experimental type of study, they say, tell us your sample size and what are the assumptions you made about sample size. And so most of us think about it as it's a checkbox that we have to include when we are submitting our manuscript for the methodology check. And many journal articles, and many journal will have a methodology reviewer that makes sure that the stats all holds together. But I think we should just pull it back up a level, which is the original need for sample size was, is there an ethical consideration when we expose someone to an intervention? And it sounds perhaps, I mean, there might be the rare exception in education, but I think the answer is if we expose you to an educational innovation or intervention, the likelihood of true harm is not going to happen for the type of studies that are going to be experimental in nature. But if I have a drug, I don't want to expose unnecessarily too many people to the drug in the eventuality that there turns out to be a side effect of the drug. The real reason we do sample size is because experiments are hard. All research is hard. And so there's always a cost. In the educational world, it's usually an opportunity in a human factors and in a personnel or just a time cost. Sometimes there is a bit of a feature. So you want to be parsimonious or parsimonious. There we go. I'm trying to use big words because I'm nervous here on the methods.
Words, man,
on the methods consult. We want to make sure that we use whatever limited resources we have as education scholars to answer our question most efficiently.
So then when we're doing that and trying to be efficient, because then people use phrases like power calculation and sample size calculations, and I can understand why you want to be thinking about that in terms of drug trials and those sorts of things. But how does it work in education?
Okay. Let's start with an example. So I am going to make up a fake study. This is not a study I've done. Okay. So that helps take the abstract and make it real. I have a partial task trainer that is going to be my big innovation to teach people how to do central lines. And so I'm going to do a study that says my simulated teaching method is going to be compared to nothing. Or I might compare it to watching a video of me putting in a central line and give you a review article. So, and the question is my innovation going to lead to better learning on the part of the participant? So the first question is, we do that study, we get some data on outcomes. Maybe I have them perform a real central line and then measure them using some kind of scorecard, or maybe I give them a quiz about all the essential features in performing a central line, and I get a score at the end of that. The first question I really want to know is there a difference? And is it true? And we do stats to see if that difference is reflecting a true outcome, or is it just random? And if I say that there is a difference between those two groups, but it turns out to happen by randomness, that's called a type 1 error. Now, let's say we do the same study and there's no difference in scores. It turns out that using my partial task trainer is no better than watching the movie. The question that we then have is, did we miss something? Was there a signal there, but it's been hidden by the randomness that is in our population? And that's called a type 2 error. And a type 2 error is when we say the null hypothesis, there's no difference between the two groups, holds. And it's an error because there actually is a difference. And the reason there's a difference is because we don't have enough power to detect a difference. Now, here's where the eyes start to glaze over.
I'm still with you, but barely, yeah.
So power is what's the probability? How likely will I be able to reject the null hypothesis? Will I actually be rejecting the null hypothesis is a fancy word of saying there's actually a difference between these two groups, between the partial task trainer versus watching the movie.
Yep.
And you can change power with three things: sample size, which we're going to get to, how many participants we have in our study, alpha, which is a funny word, but it comes back to our statement of maybe random chance. And so the quick answer, too long didn't read, is we set that at 0.05 or 5%. And what we're saying is, if I did this study 20 times, one time out of 20, there would be a difference just by randomness. The other 19 out of 20 times, a signal shows a true signal. And that's based on some statistical machinations we can do. Okay, so we actually know that 5% is like legit. So 5% is just convention. So every time we want to talk about differences that have meaning, we set it at, we'll take a 5% risk, or 1 out of 20, that the differences would just have happened by chance.
Okay.
Because you take 1,000 monkeys on 1,000 typewriters, eventually the great American novel takes place, and that's just randomness.
Okay.
If I do this, my sim study versus my movie study, 20 times, we want a difference to happen by chance only once. And so when you're doing a power calculation, it's almost convention to say, I'm going to set my alpha at 0.05 or 5%. So sample size, the likelihood that you commit a type 1 error, so that's you're setting your alpha. And then the last size is the effect size. And so effect size is how big a difference is going to happen with your intervention. And you can't set that. You can't change that. It's just how much more powerful is my partial task trainer? Is it like an amazing partial task trainer? Does it have haptics and flashy lights? Does it look just amazing? And I guess the comparison is, well, no comparison. And so back in the battle days, we do innovations against controls. And you know what? The worst educational intervention of all time, me giving a lecture, is probably the worst. Me doing a podcast would be second worst educational intervention. No matter how bad I am on this podcast, learning still happens. And the effect size is usually around 0.2. Which is a very, very mild effect size. We can talk about effect size a little bit more later. So when we say power, we're typically setting our power to about 80%, but there's no reason you can't go higher. And when we set it at 80%, we say, you know what, the likelihood of us saying that there is no difference, but there was a difference because we just couldn't see it, that likelihood of mistakenly accepting the null hypothesis is 20%. So convention says we most often set it to 80%. So power is a function of our alpha. So are we going to let randomness give us a signal that we can't trust? We're going to set it typically at 80%, saying, you know what, we have a 4 in 5 chance of actually being able to detect that there's a true difference that didn't get wiped out by variance in the sample. And then the effect size, which we can't really do anything about. So 2 of the things are standard in convention. And when you talk about power, everyone says 0.05 and 0.8. Let me pause there. What made sense and what didn't?
Okay, no, most of it made sense, but then I have like these little caveats in the back of my brain, right? Because like it feels like there's a bunch of caveats. Because one is that it's a convention. So that means that some of these decisions are just based on traditions, and traditions can change, and traditions are probably field specific, right? So what convention we hold is what we hold, but it feels a little fudgy when you're in a space that is holding, like, because when you're doing this kind of work, you're usually working from a positivist, post-positivist orientation. You have an objectivist stance, which means you're trying to have unbiased, controlled sense of measuring a specific element in reality. We want to be very generalizable and all those sorts of things. And, but we decide it's a good answer based on tradition. So that gives me the
I love that you had this reservation because you're asking the post-positivist to be even more and more precise. Make sure there's no bias, make sure there's no error. And the reason we're not positivists I can't be a positivist, is there's no such thing as a true black and white. There's nothing with a perfect confidence interval around anything in my mind.
But we always trying to get closer, right?
We're trying to get closer. It's convention to set your type 1 error rate at around 5% and to set your power at 80 because it works for most things in the biomedical world, including education. But every time you report something, you say, you know what, there's still a chance, a 1 in 20 chance that our findings could have happened by chance alone. And so we should reproduce this study. I'll give it back to you. When you do a classic CGT study, usually you say you achieve sufficiency at somewhere between 15 and 25 participants. Doesn't mean it's going to work forever. There's probably going to be an exception where you can have more or less required to achieve sufficiency. But on balance, for the type of questions we're asking, for the thousands and thousands of studies have happened, it happens that same way. The same is true for when we are doing these types of experiments, when we're doing these types of interventions. Does that make you feel a bit better?
It does. But then let me ask you my other cause for pause. We're talking about medical education, and medical learners are a special cohort, right? Because we take the bell curve and then we take the top hunk, we take the top tail, and we bring them into medical school. And so part of me is like, you can't treat these populations like you would a population of a trial of a drug or a population of a trial of any old random intervention, even in a more traditional academic space, because this population isn't a standard distribution population. They're not a normal bell curve population of people. They're all fantastic. Like, you can give them your partial task trainer. We can give them nothing. We could probably give them a dancing monkey. And they're all going to come out because they're highly motivated, highly driven. If we tell them what's on the test, they'll go figure it out. And then we're not going to congratulate the monkey. We're not going to necessarily think that it's best to leave them alone either. So what do we do? Does that factor into this power calculation sample size?
No, I do feel that you're comparing me to a monkey in your comments, which is not far off from base. So remember, when we recruit you to the study, one of the good practices is we're going to randomize you to either the control or the intervention arm.
Yes.
And in that randomization, if it's been fair, we imagine your ability to learn. And I will agree that a health professional learner, by some kind of survivorship bias, is probably going to do better in terms of general ability to concentrate, to practice. There's no such thing as general learning skills, by the way, but will probably be better at performing at some of the assessments than the general population. But because we've randomized them to control or intervention, we're comparing them like to like. We're not comparing them like to general population. Now, let me ask you a question, Varpio.
No. Oh, dear.
Why have you never calculated sample size for any of your studies?
Because I'm usually trying to create a population for my study that is trying to push the breadth of the edges of the concept. So I'm trying to get a variety of people who can talk about whatever phenomenon it is I'm studying from across the full spectrum of people. So I'm looking for, if I'm talking about residents and I want to get a senior and junior, I want to get some that came from a rural context to an urban context. I want to get all kinds of gender identity representations because I'm trying to understand the breadth and depth of this phenomenon. Sometimes if the phenomenon is really narrow, then the population can be more narrow. If the phenomenon's broader, then my population's going to be broader. But I never know how many people I'm going to be asking to try to figure it out. How do you though? Because like you figure out your population size ahead of time.
Well, there's the rub. It's a bit of a lie.
Oh.
You talk to any methodologist, and again, I'm not a psychometrician. I'm just playing one for the purposes of our 15-minute conversation here. Is we set by convention our alpha, the risk of saying a different exists that just happened by chance. By convention, we set our power at 80. You can go higher. To say, you know what, the likelihood of missing a true signal when it's confounded by variance in the data.
Mm-hmm.
And we're stuck really with effect size being one of those determinants of what our sample needs to be. And the effect size, we don't know. Now, I chose this idea of a simulation study because you could probably go to the literature and say, what other simulation partial task trainers, what has been the effect size in those studies? And Dave Cook is someone who's done a whole bunch of comparative effectiveness studies looking at technology enhanced learning. And if you don't know that literature, you're missing something awesome.
Yeah,
it's really
good stuff in there. Yeah.
It's a little biased because I did some of the work in some of the subset of his data there. So I should be suggesting my conflict of interest there. But it's really good. So you probably could find it. But I bet you if you have something that's, but there's no chance I could publish a study today on using a partial task trainer to teach someone how to put in a central line, because that study's been done 1 million times.
Yeah, of course it has.
So the effectiveness, the effect size of these interventions are probably known in the literature. But if I come up with my new innovation, which is transmagnetic stimulation, I give you a magnet across your brain and see if I can improve your working memory. Seems a great idea to me.
No.
We probably don't know what the answer is because no one's done that yet to learn how to maybe if I give you a big magnetic or electric shock across your brain before you do your central line, maybe you learn faster.
I'm not going to play your game. You do that once, you're going to watch me whack you upside the head. I'm not going to do that.
What you have to do is you have to take a bit of convention saying, okay, I kind of feel it's going to be this, it's going to be that. And we kind of manipulate the numbers on the back end to say, okay, I've set my alpha, I've set my power. I think I'm going to look for an effect size of X. So effect size allows us to compare outcomes across studies that are kind of similar but not identical. If I want to see how many heart attacks happen with my drug versus your drug, as long as the drugs are pretty common, those are pretty apples to apples comparison. If I want to see what's the best way to teach putting in a central line, is it a movie? Is it a lecture? Is it mastery learning?
Dancing monkey.
Is it
dancing monkey?
Is it my lecture from a dancing monkey? Is it my partial task trainer? It's apples to fruit. Like the comparison's not great. And so we take that absolute difference or that relative difference and we try to do a conversion. And one of the common conversions we talk about is Cohen's D. And Cohen's D essentially is a way to represent as a ratio the differences in terms of effect. And so when we talk of a Cohen's D of 0.2, we talk of 1/5 of a standard deviation. 0.8 would be 4/5 of a standard deviation around the point. All right. And so a difference of an effect size of 0.2 is mild. 0.5 by convention is moderate, and an effect size of 0.8 by convention is large. And so if you have a lot of money then you can say, I'm going to do a study that uses a small effect size. I want to see any kind of difference. I want to justify it. And so then I'm going to use a very small effect size of 0.2. If I have no money, I'm going to say, I'm going to choose a very large effect size because I can't afford to do that many. And then the numbers fall out. So when you see the cardiologists doing studies, they're adding drug upon drug upon drug upon drug upon drug. And this last little drug has got to make some difference in whether you're going to have a heart attack or not. So they go to pharma and say, give us millions and millions and millions of dollars because we know we can only see the smallest little effect size. We're going to see an effect size of 0.2 or less. In education, because nobody will give us anything more than a good pat on the back and an attaboy.
Attaboy.
The logistics and just kind of the feasibility of it means we're looking for large effect sizes. Otherwise, we have insufficiency. Now, let me go back to Dave's paper. We're almost out of time. People can't listen to sample size for much longer than this. Dave and Rose did an analysis of some data that they had from a larger study. So it looks only at technology enhanced learning.
Yeah.
And what they found in these 900 studies, so this is just a snapshot of the broader HPE literature,
okay,
that only 2 studies out of their 900 had a sample size sufficient to identify a small effect of 0.2.
Cool.
So 2 out of 900 could find that very small effect size. They had a big enough sample.
Wow.
And only 22% of the studies were sufficiently powered to find a large effect size, which it would be a Cohen's d of about 0.8. So why do we care about sample sizes? Coming back to all of it. Power is preset by our alpha, what we're going to determine our power at, the effect size, and how many participants we have in our study. So if we have something that we think is going to have a minimal educational intervention, we need a whole bunch of people in the study to show that effect.
Yeah.
If we think that we have something that is going to knock your boots off, it's going to make you learn so good, like G-O-O-D, good, not G-U-D. You're going to learn so good, then you probably don't need a lot of people to show it. Does that make sense?
It does make sense. But then my question is that, boy, does that hypothesis ever matter? Like, I think it's going to show a big effect. I don't think it's going to show a big effect. But the problem is you don't know until you get in there.
You don't know. You don't know. And so what you try to do is you try to take your best guess from looking at the literature. You might get some pilot data to say, okay, we're going to do some pilot data and see what kind of effect size we're seeing early on, realizing that there's going to be lots of risk of both type 1 and type 2 errors with pilot data, particularly with type 2 error. And you're just going to see what happens there, and maybe do a little bit of work before you really kind of commit yourself to this is the final version of what our experiment looks like. So in the podcast, I said, hey, don't worry about sample size. We all know that we fake it. And everybody knows that you only need 50 people in a study to show an outcome. And that's not quite true.
Really? Yeah.
Yeah. If you're going to set, with all the standard conventions, a moderate effect size, meaning a Cohen's d of 0.5, right? Half a standard deviation in effect between the intervention and the control.
Yep.
If you expect that if I expect my partial task trainer to be moderately effective, then I need about 64 participants per group. So I need close to 130 people in my study. If I think I have a rock star type of intervention, so a large effect size of 0.8 or greater, then I only need about 25 in my group. And so then I only need, then I only need 50 people to do my study. And what Dave calls me to task very appropriately for is there's very few educational interventions that we're showing such a large effect size.
Yeah, exactly.
The work that he publishes shows that many of our studies in the HPE literature, or at least a sample of many studies in the HPE literature, are underpowered.
Yeah.
There's not enough participants to show a difference when we say there's no difference to be found. In fact, if we appropriately power this, maybe we have better answers as to the best way to teach or assess or learn.
Right.
And it's probably an operational or just a practical matter of we don't have enough money or resources to conduct those big studies.
I was going to say, because we don't have the big money, we don't have the resources, and often for different programs, depending on the kinds of questions you're asking, UME, GME, CME, whatever, you don't have, having 50 participants, that's, for some people, that's, for instance, residency departments, that's their entire residency cohort for 2 or 3, 4 years. So, and then and that's hoping for a big impact. So I guess what we're saying is that, well, this is hard.
Yeah. Let's end here, because I think, enough of the stats, but here's the too long didn't read. There's only one lever you have in that you can really control. By convention, we set our risk of a random chance at 0.05, and that's generous, but you could easily set it at 0.01. That just makes it harder.
Yep.
We set our power at 80, or so 0.8.
Yep.
And you could usually set it at 0.9, but that just makes it harder.
Yep.
We can't do anything to our effect size, but to come up with our best innovation, and we can't manipulate that. So the only thing we have, if we want to see if we can appropriately detect a difference between my intervention and control, is sample size. And so if you have an awesome intervention with a massive effect size, you don't need very many people. You probably need 50. But for most of us, we're going to need 130 participants. Now, there's a couple other ways you can get around this, but that's for another methods consult. But there are some ways that you can change how you put your groups together.
Right.
But let's not make it too much more muddy.
So then how about this, Jon? Could you put some references in the description with the abstract for this methods consult, just so that people, after they hear this, are probably going to have needs for some additional readings, and to be able to, I know I'm going to need to sit down with a paper and read it more than once to make sure we get that. Could you add some attachments for that? Yeah.
So I recommend you read Dave's paper. I think it does a nice job of showing where the HP literature is. There's a great editorial from Norman and Montero, published in the BMJ, which is a little bit, I bet you it's about 15 years old now, that reference, but it pulls back the illusion that we are all a priori, very thoughtfully
right,
building our sample size. And what we're really doing is saying, hey, I don't really know, I only got so much money, but these numbers will kind of work. And as a legitimization. And I think that's the big farce, that's a big farce that I want to just kind of remind everybody about, that early to the game, that when you see that sample size, it's been done in the most generous way to the investigators to justify the fact that they could only get 60 people into their lab. And they just cross their fingers and hope to see a big effect.
Perfect. Well, Jon, thanks so much for joining me for this methods consult. I'll remind our listeners that if you want to get in touch with us, we'd love to hear your thoughts. Is there a different topic you'd like to hear a methods consult on? By all means, reach out, make a request. We do read all the letters that come in, and you can reach us at thepaperspodcast@gmail.com, or you can go on the internet and just look up Papers Podcast and you'll find us there. And so with that, Jon, thank you so much for being part of this today. And I'll say, talk to you later.
For a long-time listener, first-time caller, thanks so much for having me. Thanks for listening, everybody.
You've been listening to the Papers Podcast. We hope we made you just slightly smarter. The podcast is a production of the Unit for Teaching and Learning at the Karolinska Institutet. The executive producer today was my friend Teresa Sörö. The technical producer today was Samuel Lundberg. You can learn more about the Papers Podcast and contact us at www.thepaperspodcast.com. Thank you for listening, everybody, and thank you for all you do. Take care.